The daily commute is a common experience of nearly every Pole. Whether in a tram or a bus, or simply crossing the street, we are constantly exposed to particles suspended in the air. With every breath we take, we pull in nearly half a litre of air, and with it, many contaminants. Scientists of the TELE and Radio Research Institute investigate the effects of such contaminants on our organisms. To this end, they use mass spectrometry. The investigation process begins with an ordinarily looking, although not ordinary, black case. This case is not used to carry documents. Its purpose is to collect pollutants from the air. This process takes 24 hours. During this time, particles of dust are sucked into the personal impactor held in the case. The impactor is a distant relative of a vacuum cleaner. This device collects the particles suspended in the air, invisible to the naked eye. To this end, we use the cascade collectors, which allows us to catch dust particles and separate them into several size groups. We examine microparticles and nanoparticles. Such collected material is then investigated at the TELE and Radio Research Institute using the secondary ion mass spectrometer, or SIMS, developed at the institute. We're using a variety of research methods. One of them, called an ion sputtering method, allows for the removal of atomic layers from the surface of the solid material. In this process, we can analyze the structure and atomic composition at the consecutive layers of the sample. The spectrometer, developed at the TELE and Radio Research Institute, is a unique piece of equipment because of the innovative solutions used in its construction. The scientists applied the ion sputtering method to monitor particles that are rotated during the analysis. Atomic layers are removed from all sides of the analyzed particle. This method allows for a more accurate analysis of particles than when using standard equipment used in other laboratories in the world. Mass spectrometry allows for the analysis of layered structures used in the electronic, chemical and material engineering sectors of industry. For example, this method can be used to analyze protective layers, corrosion-proof coats, electronic nanostructures, and many others. The scientists from the TELE and Radio Research Institute recently developed a modern glow discharge mass spectrometer, or GDMS, which is increasingly used in various industrial applications. The analyzers, designed and produced at the TELE and Radio Research Institute, allow advanced research programs in environmental protection or nanotechnology to be carried out. The analysis of nanoparticles and nanostructures using a SIMS spectrometer is most exciting, as this equipment allows for measurements with more than 1 nanometer or 1 billionth part of a meter accuracy. This method presents new exciting applications and solutions on a daily basis.